Good day, everyone, and today we'll be looking at logarithmic differentiation. And in our last topic under our introductory to differentiation, we talk about product rule of three different functions. When you're having three different functions, you can apply product rule. So when you have three different functions being multiplied together, you can apply product rule to that. So yeah, also another similar case to that is logarithmic differentiation. And what is logarithmic differentiation talking about? Logarithmic differentiation is talking about when you have a function, you are trying to differentiate a function whereby you're having a product of a or quotient of two or more functions. That is, you're having a product or quotient of two or more functions. Then you can apply a kind of a method called logarithmic differentiation. This can be three functions, maybe multiplied together, maybe two is multiplied, one is divided, maybe one is divided, two is multiplied. But when you have two or more functions that is joined together by maybe product or quotient, then we can also use logarithmic differentiation. So looking at this, let's say we have let's look at this now. Let's see, there are three major kind of ways. Let's say we have y equals to uv over w. This is one way. I get it now. This is one way the question can come. That is, when you have three different functions, let's say you have three or more. Yeah, I'm focusing on three. So when you have like three different functions joined together by multiplication like this, or division, or even both, I get it now. Then we can use a logarithmic differentiation. So this is a case whereby you can easily use a logarithmic differentiation way or method. Another one is, let's say you have y equals to uvw. It can be more than three functions, but it has to be more than two. That is three or more. I get it now. So basically you are basing on three. So here you have uv and w multiplied together here. And in this case here, you can also use logarithmic differentiation. Let's say we have another one. Let's say we have u over vw. So this is another case where another example whereby you can have you can use logarithmic differentiation. So basically logarithmic differentiation is usually applied when you're having three or more functions joined together through maybe product or quotient or both, something like this here. Now you have product and one quotient. I get it now. So in this way, when you have a problem like this whereby you use a function of x is well, v is a function of x, w is a function of x, and then you want to differentiate. How do you differentiate this? In this case now, you cannot use just product rule. I cannot use just quotient rule like them now. So because it's combination of literally the three of them, or in this case when you have three different functions, you can use product rule for this like we did in our last video. You can also use logarithmic differentiation. So how do you go about this problem? Let's quickly check it out. Now let's start with this. Let's start with this problem here. I get it now. So let's say we have y equals to uvw. So how do you apply logarithmic differentiation? Logarithmic differentiation is just adding your natural log to your problem. That is, you are going to be using a natural log ln x, or let's say we have log e base x. They are basically the same. I get it now, because this is a natural log of x, which can also be written as log in base ex. I get it now. So this and this are the same thing. So this logarithmic differentiation, just like the question topic says, logarithmic, you're applying a kind of log to your differentiation. That is a kind of a natural log in this case here. So either I use this or I use this. So x here is the whatsoever problem we are dealing with. I get it now. So in this case here, we are going to add ln to both sides. Let's try and solve this problem here. If you add ln to both sides, you have ln y. I get it now, equals to ln uv over w. I get it now. So this is your problem here. I get it now. So this is ln y equals ln uvw. So from this case now, I said that we have a problem like this is a 3 problem here, and you are trying to solve a kind of problem where you have multiplication and quotient. I picked one example, which is this one, to try and illustrate that for you. Okay, so adding lane to both sides, what are we going to get when you have this? So here we have lane y equals to, this one give us lane u plus lane v minus lane w. So how did we get this? How do we get this here? It's very simple. It's gotten from your log. Anything, no, lane is natural log. This lane x means natural log of x. I don't know. So your normal logarithm just log of x. This is natural log of x. So anything log can do, lane can also do. So if I have log ab over c, what does it mean? If I have log ab, it means log a plus log b. In this case now, log a will be what? Log a plus what? Log b, and divide by c will be minus log c. Do you get it now? So in this case, when you have log a plus b, anything you can do for log, you can also do for lane. So log a plus b gives me this, divide by c, it gives me minus c. So in this case here too, anytime you're having lane something, anything you can perform for log, you can also perform for lane. I get that, because lane is still a natural log. Do you get it now? So lane uv over w is simple as what? Lane u plus lane v minus lane w. So do you get the logic now? So from here, what do we do? So here we have all this here. So what do we do here? Now we now differentiate. I get it now. Now if you differentiate, another problem which I want to solve here. Now if you differentiate lane x, the answer is 1 over x, right? From our previous video on derivative of trigonometric functions using chain rule and likes. So in case you have not watched that, you have to go and check it out. So if you have lane x, derivative of lane x is 1 over x times differentiation of x. That is the actual thing you are doing. I get it now, because derivative of 1 over x is derivation of lane x. If I differentiate lane x, it is 1 over x times differentiation of whatsoever I have here, and differentiation of this x here will give me 1, and 1 times 1 over x. So here I have 1 times 1 over x times 1, which gives me 1 over x. That is why the derivative of lane x is 1 over x, not because it is just 1 over x. You first start with 1 over that problem, and then you differentiate whatever I have in. That is, if I have lane 5x squared, if I want to find the derivative of this, it is same thing as what? 1 over 5x squared times differentiation of this, which is what? 10x. I get it now. So from here, 1 will cancel 1 here, 5 here, 1, 5 here, 2. So you have 2 over x. Do you get it now? It is not just the answer is 1 over 5x. If you check our previous video, you get more understanding about that. So because of what I want to do here, I digressed a little bit. Alright, so from there, what do we do next? So from here, derivative of lane y is same thing as 1 over y times derivative of y, which is dy dx. I get it now. And derivative of the u will be 1 over u times du dx. And also derivative of lane v will be 1 over v times what? Dv dx, because u, v, and w are functions of x, minus, because it's minus here. Derivative of lane w is what? 1 over w times differentiation of w will give me w over dx. I get it now. So this is how you furthermore solve problem. So from this place now, I can bring y here and now get my dy dx, because what I'm trying to do is differentiate y with respect to x. So at this point here, I'll get my dy dx when I bring this one here, and then I'll get my final answer. I get it now. So this is just for problems when you have something in this case. I get it now. So when you have a problem that is looking like this, as you having 3 different three or more functions that is being joined together, maybe through product and quotient like this, then you are just all you just need to do is apply the logarithmic differentiation method, that is inputting your link to both sides, then furthermore simplifying, and then you get your more simpler solution. I get it now. All right, so let me look at what about the other one too. So what about the other ones? What if you have a y? Another example, let's say uh, what if you have y equals to u over vw? So how do you go about that? It's very simple. Same thing we did there, we did here. So add lane, add lane, add lane. So eventually you have what? Lane y equals to lane what? U over vw, which eventually gives us what? 1 over y, just like this, equals to dy dx. I guess now I'm dropping step plus what? 1 over u du dx. I get it now. Because this is going to be negative, I get it now. This one is going to be minus this one here. Give me what? 1 over v dv dx minus same thing goes to the other one, 1 over w dw dx. Let me write it more properly. Let's say, all right, so lane y is lane y here, and your equals to lane u over vw. Give me lane u minus, because this is just like log u over this will give me log u minus everything here is plus. If I open the bracket with a minus, I have minus minus. I get it now. So from here I can differentiate it, differentiate this to get 1 over y equals to dy dx, 1 over this, 1 over that, just like this. Then the only difference between this one here and this one here is that this one you carry negative, that is this negative here, it's not carry negative, why this also carry negative. So that's the only difference. And also in the case of when you have a 3, something like this, let's say you have just like your your derivative of a 3 function product through using 3 functions like this, is still the same thing as having your what? Lane y equals to lane u plus what? Lane v plus lane w. I get it, because I add lane to this side. So you have lane this, and log a b c is same thing as log a plus log b plus log c. So same thing here, lane this, you gain lane this. And then when I simplify, I have 1 over this, 1 over this, 1 over this, 1 over this dx differentiation. So in that case, eventually I have positive here, and I will still get this solution. I get it now. So because of our time, I'm not elaborating on that. All right, so let's take a look at this example here. That's the example: y equals to x squared sine x cos 2x, and then you are trying to find dy dx, find dy dx. So what will you do in this problem here? You know, if I find dy dx, I cannot just, there's nothing to use here. In this case now, in a normal setting, this is not only quotient, there's product, things like this. So in this case, whereby I have 3 functions like this or more, but basically for your level is, let's say, like 3 functions that is joined together by product or product and quotient like this, then you just apply logarithmic method. And what do you do here? Apply your link to everything. So apply link to both sides. So you have what? Lane y equals to lane, I get it now, lane x square, I get it, x square sine x over cos 2x. I get it now. So from here, what do we do? So from here, since I apply lane to both sides, so this one gives me lane y equals to lane, this will give me what? Lane x square, I get it now, plus lane sine x, I get it now, minus lane cos 2x. That is, you know what this means now. So lane a b, just like your comma what I just said, then AB over C is same thing as log AB over C, which is log A. If I have log AB, same thing as log A plus log B, and divide by C will be minus log C. So same thing here, which I've been doing is what I did here. So here also, from here we now differentiate. So differentiating, the next step is differentiating everything we have here. So differentiating y, differentiating in y here, we have 1 over y times dy dx. I get it now, which is 1 over y times the differentiation of this y, which is dy dx, equals to ln x square. Here ln x square will be differentiation of ln x will be 1 over x square. I get in times differentiation of x square, which will give me what? Will give me 2x. I get it now, which will give me 2x. So differentiation of x square will give me 2x here, plus then this will give me 1 over sine x. So ln x, ln sine x. So we have, alright, so ln sine x will give me 1 over sine x times differentiation of sine x will give me cos x, in brackets cos x. I get it now, minus ln this will give me 1 over cos 2x. I get it now, cos 2x, open bracket, differentiation of cos 2x will give me minus 2, differentiation of cos will give me sine, rather, sorry, it will give me minus sine. I get it now. No, you remember how we do this, that is differentiation of 2x give me 2, differentiation of cos will give me minus sine, that's minus sine and your 2x. And if you don't remember how we did this, you have to go and check our previous video on this kind of problem, and we've done that. Probably I'll drop in the description below. Logarithmic differentiation, I say logarithmic, that's trigonometric differentiation. So differentiation of cos 2x give me 2, differentiation of cos give me minus sine, and 2x you have there. I get it now. So from this place you have dy dx is dy dx is equals to, bringing this to this side, y to the other side, we have y. I get it now, open bracket, you have this with 1x here, it's going to cancel 1x here. So what do you have left? You have what? 2 over x. I get it now, plus this will give me sine, cos over sine, this will give me cos x. I there, this will give me cos x over sine x, and this will give me minus as minus here, give me plus 2 sine, plus 2 sine 2x over cos 2x. I get it now. So we have this. So what is the value of our y? Let's replace y with this value here. What do we have? Okay, so and y is equals to this. So I've replaced y with this here, and then in bracket we have 2 over x plus cos x over sine x plus 2 sine 2x over cos 2x. You get it? So we have this. So from here we can expand this. So when we expand, what do we have? So we have dy dx is equals to, so this times this x here will cancel x here, we have only x left here. So we have 2x sine x over 2, sorry, over cos 2x. This times this will give me sine here will cancel the sine here, so we have only x square cos, that's plus, you get it, plus x square plus this times this sine cancel, so we have only this, we have x square cos x over, this is already 1 over cos 2x. I get it now. So this time this also give me what? So here, is there anything canceling anything? I don't think so. So we have 2x squared sine x cos, sorry, sine x sine 2x ID over cos square 2x, because cos 2x cos 2x give me cos square 2x, and there goes our answer. So this is the answer for that problem. And if you look at it now, this is how you solve that kind of problem. So you can also see, try some cases of the other kind of problem, that is in case of u vw u over vw. You can see examples on that and try it. So there's something I want you to try. I think I have one problem we did in our last video under differentiation of three different functions, and I want to see if you get the same answer. I think the problem is y equals to, let's say, x squared sine x ln, I think it's ln x or something like that. Trying to remember, it's something like this. So we have to solve this and see if you get the same answer as what we got in that previous video under differentiation of three different functions. If you get the same answer, then you are correct. So this is our try this question for today, and don't forget to subscribe and also share to those who need and to those who are in need of this video. So I'll see you in the next video, hopefully.